So this is going to be the first uh, viewer Verilog question. I'm gonna just upload a bunch of videos today, and hopefully some of you will enjoy. I would do live streaming, but I'm not really confident in either my equipment to just not crash in the middle, and I'm definitely not confident in my skills as a programmer. Because I might get stuck for like 3 hours. Like, what if I get stuck for 3 hours and then it's just like gonna be a waste of everyone's time? So no, not gonna live stream until I get a little bit more videos under my belt. But rest assured, this whole scenario, if I do upload it, it is live and I have no preparation a priori, if that isn't immediately obvious. So let's dig into this problem. Um, Hello, can you explain this interview question? Write Verilog dot which counts up to 7 and then down to 0 and repeats forever as follows. Observe that there's a double forward during counting. On reset, the counter starts at 0, increments by unity. You mean by 1, I guess? By unity. Okay. Yeah, I mean, the hardest part of this problem seems like parsing this. And then decrements by unity, which I guess also means just 1 on every clock up to 0, but observe that during decrement, number 4 repeats for 2 clock cycles. And he even gives me this. So this is, okay, I'll just copy this. And then over here, I'm just gonna, so this is what I did yesterday night. I'm just gonna copy this so that I can not overwrite my old changes. And yeah, I got some nice protein powder. It's peanut butter and jelly protein powder by Steel Supplements, and I'm drinking it, and it's both delightful and disgusting at the same time. Like, it tastes really good, but it tastes so artificial. You're just like, ugh, well, ugh. So I mean, the taste up front is like very good, but then the aftertaste is uh most definitely suspect. So um all this to say, if I'm pausing for a very long time, it's probably because I'm drinking my protein powder, or more than likely it's because I'm stuck. So all right. So basically this just wants count up to 7 and then count down to 0 and observe that 4 repeats every 2 cycles. So I'm just gonna rename this to useless counter because that's what it is. And if they give you a signature like this, so in software interviews, it's probably more common to give you a method signature. In hardware interviews, I wouldn't give them the signature as explicitly because there's a question I want them to ask me. I also don't like reset as opposed to reset n, just because conventionally most companies do reset n as opposed to reset. So I'm just going to tweak this question to be reset. And obviously, if the interview gives you this question, then you just want to do reset. And then the other thing is, so output logic to 0 count, right? So another thing that like I would require if I was asking the question was this, is this an enable signal? Because most of the time in like a real application, you need some qualifier to say, well, on these cycles, the handshake or the token count or whatever isn't valid, and then so I'm not going to enable it. But this is just a forever sort of counter that just does something seems like arbitrary, so I'm just gonna just go with the problem. Actually, instead of reset, and I'm just gonna go with reset because this is just in the spirit of this homework textbook problem. So let's just do it like that. Let's not get too clever here. And also maybe then this viewer would subscribe and or like my videos, you know. What up? the things I do for a like, you know what I'm saying? Like, all right, and then logic count. So, all right, so, let's do this. So it's pause edge reset. Man, that Twitch, I'm always thinking about that reset N. It's not, it's just reset. The hell? All right, so on reset counter 0, done, because I just do this. Okay, increments on every clock by 7, except when it decrements. Observe that. Okay, so it's just trying to implement this for the rest of the problem. Once begin end, if up count begin end, else if down count begin end. And up count's just gonna be, let's do this so it compiles. Is when count is, you could do 3 to 0. I prefer to do this because I'm a bit lazy. Or if you want to do this is okay. Like, I don't think this is too convoluted, because if you're someone that reads a lot of Verilog, tilde or is 0. So this is saying that I'm going to take all the bits and reduce it. So if any bit is 1, this term would be 1, and if I not it will be 0. So the only time this will be 1 is if count is 0. But I think just to keep things a little straightforward, I'll do this. Likewise, like that. Likewise, this you could just pretty easily say and count, right? So this is only a value to 1 if all its bits is 1, if you do and reduction. So 1 and 1 and 1 would be 1, but any other case it'd be 0. But let's just say, all right, it's just 1. I'm pretty sure if you synthesize it like this, it'll just do a reduction anyway. All right, so basically, yeah, if I'm 0, then I will count up. Else if I'm down count, like, oh yeah, I've hit 7, then I'm gonna start counting down. Now I need to do a special case of 4. So if I'm in the down count and I basically need to stutter for a cycle if I'm hitting 4. So if so I cannot just say and then just stay for a cycle. And the reason behind that is because then you have an infinite loop, because you just keep flopping 4 to 4, right? So yeah. So what you might do is you just have a first status bit, so like first 4. So the first time you encounter 4, so I don't know why, like, some of my coworkers do like and like, it's not software. Like, Verilog isn't software. This is just an AND gate. You're synthesizing AND gate. This is a 1-bit input, and this is on the right hand side another 1-bit input. So like and just shows that, like, and will create a priority AND gate for basically no reason. And what is even a priority AND gate? Just use single AND. If you're writing hardware, if you're using software, then you can do and. But if you're using and, that means you're not using Python. If you're not using Python, then Anyway, I'm wasting everyone's time, so I'm just gonna yeah. So first 4 is gonna be Actually, let's just do solve for, and then I'm just gonna do this, and else if count is 3d4 and not solve for, right? Begin end. Um, well, actually, yeah, you don't really need to do much here. Right? So solve for will be 0. So did I see a 4? No, I didn't see a 4 at reset. And then if I'm gonna count and I didn't see my 4, for example, then this would be 0. And all this would do is just to flip the switch so that the next cycle, this would be a 1, and then I would kind of continue counting. But now when I continue counting, then I want to do solve for. So this will set it back. It'll set it back. So 0 to 1, and then 1 back to 0. And then this is so that if you are on the up count, if you're on the up count, these two won't be modified. And then next time when you're coming down again, your solve for would be reset to 0 because of this. And when it has been reset to 0, it might be a little bit better to just do it like this, just to be safer and more maintainable. And you might do it like this if you want, if you don't want to be clever. All right, let's not be clever in interviews, because yeah, this is more maintainable. And anyway, end else begin end. Cool. Right, so I'm gonna sip protein and think about what I just wrote. All right, so reset is 0, and then when I go to a down count, coming back down, this will be a 0, so this won't hit, but this will hit. If it's a 4, it'll set this to a 1. Next cycle, this will continue counting down. And the cycle after, the count won't be 4 anymore, so just keep counting down until it hits 0. If it's hit 0, the up count will go to 1, and it'll count up again all the way up until 7. In which case, down count will assert, and then it will just do this. And then so, yeah, I don't know. Let's instantiate this, and then let's try to compile it. Just to make sure that I didn't make any blunders as far as like syntax goes. Yep. Speaking of blunders, 1 bit, 1 bit, 3 bit, 113. Cool. No semicolon here. What am I doing? Clock is 0. Reset is 1. Count. I don't need to do anything. Let me just run this. See what the hell is going on. Wow. Anyway, then let's do a task. Just print count, right? And clock, and begin, end, and task, and then I care. There's no real inputs, so I guess it kind of doesn't matter to me if it's printing out this cycle or the next cycle. So I'm just gonna say like count in decimal for easier counting, and I'm just gonna do like this, right? Okay, so the first cycle is going to be a reset. I just want to make sure that the thing's good here. Count is X. Oh, because I didn't I need to clock it once. So actually, you know what then? I'm just gonna do it like this. And then maybe just do it like that. Yeah. Let's just all right, cool. All right, count 0. So let me reset it to 0. Let's do reset 0, and then let's do like for int. Okay. Print count and clock. And see if this let's just debug this. I'm not sure if this will work at all. So count is ones all the way, so GG there. If reset is 0, I'm curious what is the up count and down count. Oh, I see. This can't be an assign because as it counts, it gets cleared. Right. All right. So, all right. If up count, then do this. So let's see. What if I do if I do up down or not down count? What happens? So down count's not going to be set till 7. So basically at 0, I'll start this up count, and then this will take me all the way to 7. But if it's 7, then down count would be 1. But then up count would be 0. I'm just curious, like, because I don't really want to like add another if else kind of a thing. But this doesn't work either. 6, 7. And then when it goes to 6, okay. All right. So I guess the solution here is basically instead of doing this assign here, you basically need to say if um, so this will count up to 7, and then here it'll count down. So this is true as long as it's not 7 though. So all right, I guess I need a state bit to kind of see if I'm up count or down count. So if I'm gonna set this up count bit, uh, uh yeah, that's quite a bit annoying. If up count begins, so This is kind of messy, but so basically my thinking is, hey, this is just a zero check. If I'm at 0, then I just want to turn this up direction to 1. And then so if this is asserted in the same cycle, we do still need this here. Okay. And then here you would have to do or down direction. So basically, if this is set, so if I hit 7, I'm no longer going in the up direction, but I am going the down direction, and the converse is also true. So this up and down count, this up count will go get you from 0 to 1. But then this up direction would get you from 1 all the way till your saturation point. Because when you have your saturation point, down count is true. Yeah. So if I'm at, here's a corner case, if I'm at a 7, right, my down count asserts this cycle, but my up direction isn't going to be clear until next cycle, so you actually need to use your down count as your clear bit, and in parallel, your up count as your clear bit here. And then, yeah, let's see what happens here. I probably need to instantiate stuff. 0125765443210 0125765443210. Okay, so this is exactly what the viewer wanted. This is a little bit more complex than I thought. I think the takeaway lesson here is this motif of the tricky thing is you have these state bits or these status bits that I would call up direction, down direction. So with these status bits, you have like set or maintain and not clear, which is the motif of these two. So you would see this, in, let's say you set a status bit and you're waiting for some response from an interface, and this set signal is going to propagate to this maintain signal. So you're just going to maintain that status bit as high until something comes back, i.e. that response comes back, and you clear it, and then you kill the signal. And then so this motif here, you see a lot in sort of like interface level control signals. And so this is one way to do it, but this implies that if you're setting and clearing in the same cycle, that the set takes precedence, which may be the case depending on your interface. In this case, it's not possible for set and clear the same cycle because the 0 and 7 are 7 or 8 cycles apart. If you want the clear to take the precedence, like the response comes back, but then you don't care about your setting, then you just do it like this, right? So anyway, that's it for this problem, and I'll see you in the next one.